Okay, so this one, so let's see the mechanism. Okay, I will write just this generic structure. So see this nitrogen of nitrile has a lone pair, so it's basic. Okay, and then you have acidic condition. So this same as carbonyl, this will be protonated with the acid. So it will form that nitronium ion type. So as soon as this forms, the carbon of nitrile becomes more electrophilic. Okay, so water here, the reaction happens in water under the acidic condition. So this will react quickly here. So this will form so this will be deprotonated again whenever oxygen plus such type of forms it gets deprotonated. And remember these reactions are reversible. So here and then you will have RCNH Okay. See this nitrogen is as these reactions are reversible, this will be um, protonated again under acidic condition. So here you'll get RC nitrogen positive charge, okay, and OH. So this OH, it's acid catalyzed. This will be removed and you see this will go here. You can show this one via uh, the ionic intermediate as well, but you can go directly on this. So this one here, this is the amide intermediate. Okay, amide intermediate forms. So this amide intermediate under acidic condition and heating, it will not stop here. It will further react, okay? Again, reaction with the acid. Now this, you have nitrogen lone pair, oxygen lone pair. So both of them can react, but oxygen will react, will get protonated. So it will be O plus NH2. Okay. And then water molecule will again will be added here. So this will go here. So here it will form the tetrahedral intermediate. Okay. So this will be deprotonated and this nitrogen will be protonated. Okay. So this will be protonated from the solvent. You can show the 2-step or 1-step is also fine. Okay, here you have that OH. So what will be this one? So it's kind of geminal diol and NH3. Okay. So next step, what will happen here? This will be deprotonated. We'll make the double bond. Let me write more clear. So here, okay? And water molecule will take this proton, this will go here, and this will leave. So what will be the product? The product will be carboxylic acid. Sorry, here OH. Okay, so this is the final product, and here ammonia will be the byproduct which will react further with the acid and will give the product. Okay, so this mechanism, this type of mechanism will come again. Okay, so just all the repetition, but all of the similar steps. Okay, if you go one by one, it should not be a problem. What is this going on? Okay. Okay, so next step, this reaction can happen in a basic medium as well. So basic medium, it is slightly different. So if you have, say, nitrile, and you take a strong base, let's say sodium hydroxide. Okay. So this carbon is electrophilic, delta positive, and this nitrogen is delta negative. So what will happen? This OH minus will add here. Okay. So this one will make nitrogen minus, and then here you will have OH. So this N minus will take a proton. So this is a base catalyzed reaction. Okay, it will take the proton. So here it will be NH. See, carbon double bond nitrogen is imine type intermediate. Okay. So next step, what will happen? This again will take under basic condition. This OH is acidic. So this will come here, and this will take a proton from water. Okay. So what will be the product? The product will be, here now you will have NH2. And you will have a double bond. Okay, do you see this? You guys can see this is an amide intermediate. Okay, amide intermediate. So here again, because the reaction is in basic condition, so OH minus from NaOH will react again. Okay. So this one OH minus, so this OH minus, as soon as it will react, and this will come here. Okay. So like that before a structure, it will have the tetrahedral intermediate. See, and all these steps are reversible. Okay. And this will go back and this will leave this time. Oxygen, this also can leave, okay? But see, in that case, you will get the backward product. So when NH2 will leave, so you will have the expected product, OH. Okay? And this, because it's a basic condition, so you'll have NOH minus, this acid base reaction will happen instantly and you will get the salt. And when you do acid workup, quench the reaction with an acid, it will take the proton and then you get carboxylic acid. Okay, so this is a acid base reaction. So both under both condition, the nitriles can be hydrolyzed to carboxylic acid. Okay, I will give you guys a practical example. I think you guys will have to do next lab this hydrolysis reaction. This one under basic condition, or maybe both acidic and basic condition. Okay, so if you take this one, I will show you guys a kind of multi-step here. This intermediate, okay? So it's an alcohol, and if you react this one with SOCl2, what will happen? SOCl2 converts the OH to Cl. Okay, Cl. Okay, this reaction you guys have seen many times. Then you take sodium cyanide. What will happen now? SN2 reaction. See this, try to understand this, very important, will be helpful for multi-step synthesis, okay? So this one will be that CN. Okay? So if we'll do acid catalyzed reaction hydrolysis and heat it, reflux. So what will happen? The nitrile will convert into an acid. Okay? And this is ibuprofen. Okay? The same, if the same thing you take under basic condition, so what will happen? Just we saw the mechanism, it will make a carboxylate. Okay. And then if you do acid workup, then this O minus will take this plus and you get the ibuprofen. Okay. So this is the I don't know what is this. It is just crashes out. Sometimes it doesn't work. What's wrong with this? Did it save? It didn't save. Okay, I hope you guys have seen, you guys understood that one. And we'll do problem. In the book also, there are several are there examples, so try to do those, okay? Any question in this mechanism? So both acid and basic catalyzed hydrolysis of nitrile can give carboxylic acid. Okay, so this is the method to make carboxylic acid. So here basically the reaction of an anion with carbon dioxide, okay, will make we can react with carbon dioxide to give carboxylic acid, like Grignard reagent is the best example. Okay, so just 2-3 methods. Another method to make nitrile, okay. So nitrile, I showed you guys that one SN2 reaction can make nitrile. Another method of making nitriles is amide. Okay, amide functional group is ubiquitous. You can find a lot of that natural products or materials that contain the amide functional group. When this is reacted with sulfonyl chloride, okay, you guys remember this reagent is used to convert OH to Cl. If this one is used, then what happens? It can convert the amide into nitrile. Remember this one. Okay. So how does this reaction happen? So see the mechanism. See, this is as SOCl. So here sulfur is highly electrophilic. So what happens? This will come here and this will react with this. And this will go there. So what will be the product? The product will be RO attached with sulfur, and sulfur will have O minus and it will have 2 Cls. Can write the intermediate like this. And the nitrogen, this carbon nitrogen will have a double bond and nitrogen plus. Okay, let's say this one. So now this negative charge will come back and one of the chlorines will leave. In the same time, this carbon and nitrogen hydrogen bond will be broken and proton will be removed. So what will be the, based on the arrows, what will be the product? So RCO S double bond OCl, okay, and this, okay. Overall, this is a very, very good leaving group. Remember this one, very good leaving group. So what will happen? This bond will break and this will go and chlorine will leave. Okay. So what will be the product? The product is the carbon triple bond nitrogen now, and sulfur dioxide gas will be released, and HCl will be the byproduct. C from H from here and Cl minus from here. Okay. So this is a two-step mechanism, not very long, but very try to understand this one. That when oxygen sulfur bond forms, that makes a very good behaving group. Okay. Any question? Okay. So these are the methods of synthesizing the nitriles and carboxylic acids. Now let's talk about the reactions. So we'll talk more about, you guys know so far we have discussed the carboxylic acid reactions. So I will just review the old reactions because the next chapter will come again special about the carboxylic acid reaction. So it can react with base, like see any base can react with carboxylic acid and it will make a salt because it's an acid base reaction. Okay. So remember these, you should have very clear concept. So it will make pyridinium salt. If you even take water, what will happen? Water, because it's an acid, will take this proton. So, sorry, here CO minus plus H3, it will be ionized. Okay. Another reaction you guys have seen that if you take SOCl2, what will happen? This OH will be gone and acyl chloride will form. This reaction will come again. Okay. Now the reactions of nitriles. Okay, this is the reaction of reactions. So what is the reaction just we saw? Hydrolysis with water hydrolysis and heat, what it will form? The long mechanism we did, it will make carboxylic acid. Okay. This can be done also in under basic condition. One reaction you guys should remember important is that if you react with the Grignard reagent, okay, so this is say negative charge, here positive charge Grignard reagent, this can react and like a pi bond because it has delta positive, nitrogen has delta negative. Okay. So what it will form? It will form carbon double bond, nitrogen negative charge, magnesium bromide will be as a counter ion, and methyl will be added. Okay. So this will be the intermediate. So what happens in Grignard reagent when we work up an acidic condition by adding acid? So what happens? This O minus will take this proton, sorry, nitrogen minus will take this proton, it will make NH, CH3. Okay? See, the condition is acidic, and what is this product? Imine. You remember in the last chapter, imine. So under acidic condition, this one is very, very unstable. Unstable in acidic condition. So what will happen? It will be immediately hydrolyzed. Again, acid, it will react. So it will make RC double bond H plus CH3. You can see this one here, minium, because its nitrogen is basic, and you have water molecule here. It will immediately react in the next step. Okay. So what it will form? It will form R NH2 CH3 OH. Okay. So this one, what we in the next step, oxygen will break off, and this one will take from a proton from water because acidic condition, and this bond will break off, and the product will be a ketone. Okay. So this will be the product. So long story short, here the reaction of Grignard reagent with nitrile will make a ketone. Okay, via imine intermediate. Why it will make ketone? Because imines are very, very unstable under acidic condition. Okay, any question? So these, I think these are the reactions we have this. Yeah, I don't know if we have. Okay, one more reaction. Reduction of nitriles, because remember this one, reduction of nitriles. So this nitrile can be reduced. See, it has 2 pi bonds, carbon nitrogen 2 pi bonds. So at high pressure, palladium, charcoal, and carbon can remove those 2 pi bonds, and it can make an amine. Okay. Another reagent can do this job is lithium aluminum hydride. Okay. By the way, I will remind you guys, carboxylic acid also can react with lithium aluminum hydride. We have done this reaction, and it was in the last test as well. What it will form? It will form a primary alcohol. So just don't forget this, because lithium aluminum hydride is a very strong reducing agent. Okay. So how lithium aluminum hydride does the reduction? See, this lithium aluminum hydride is a hydride, very good hydride source. See, lithium aluminum hydride means lithium plus AlH4 minus. like this. Okay. So lithium kind of Lewis acid. First, what will happen? This nitrogen lone pair will act as a base and it will be protonated and it will form lead, nitrogen plus. Okay. And this next step is aluminum, that's minus. It's a very good hydride donor. Okay. So one hydride will be shifted to the carbon and nitrogen will form, and here you will have this lithium, and you have Al. Now you have this one here. So this lithium will be exchanged with aluminum. So what will happen? RCH double bond nitrogen AlH3 minus. Okay. So now another hydride will come from another molecule of lithium aluminum hydride. Same kind of repetition. So we'll have RCH. So now both the pi bonds are gone. So nitrogen has kind of negative charge here, two negative charges. Or you can say here, if you want to write AlH3 minus, it's okay. So when you do acidic workup, H plus, so it will react with two H pluses. See, one the negative charge, another this one. And then it will make NH2. This is the product. So in fact, both will give the same product, lithium aluminum hydride under high pressure of hydrogen, or that lithium or hydrogen palladium charcoal or lithium aluminum hydride. Okay, any question?